Hey all, this is Derek and this is 7.3 division with polynomials, and we're going to look at two basic forms of that. Long division, which is exactly what it sounds like, the same as what we did in 4th grade, where this goes into that so many times and bring it down and subtract. And then we're going to do something a little bit different called synthetic division, which the first time you watch me do it, you're going to think it looks confusing and mysterious and not like it, sort of. And that's people's initial reaction to it. And then once you see how really easy and clean it is, it's actually a really great way to solve these. It doesn't always work though, dependent on the form. And so if we have a number in front of whatever we're dividing by, the divisor, so like here it's x plus 5, the coefficient on that x is just a 1, that would be a great place to use synthetic division. That's where this works really well. If this is a 2 or something other than a 1, that's where we can start needing to use long division depending on what we're doing with it. The other place where long division is really good is, and we'll see a couple problems coming up, is when we have when we skip a term in here and we have to try to keep things aligned. That gets really hard in this formatting. So there's a few places where long division is going to be the better choice or the only choice, but synthetic division is so much easier when it's available. So let me show you both. And to start, I'm actually going to do one that is, well, synthetic is actually still almost easier, but I'm going to do this by dividing by factoring. And we'll see this coming up in the next chapter, but it's the basic idea that if I have 10 over 15, I can factor and reduce. So I can write this as 5 times 2, I can write this 15 as 5 times 3, and 5 over 5 is 1, and that reduces my fraction. It gets me to 2/3. So reducing is a form of division. We're just reducing out the factors of 1. And I can do that with polynomials as well. So here, this is x squared plus 15x plus 50. So we're looking for two numbers that multiply to be 50 and add to be 15. So that would be x plus 5 and x plus 10 multiplies to 50, adds to 15. That's over x plus 5. And so then you can see x plus 5 over x plus 5, that would equal 1. And so then what's left is x plus 10. So that would be, if factoring is available and the factoring is pretty straightforward, this is a pretty good way to do this problem. And like I said, we'll actually start the next chapter with this method. But that's just previewing a little bit. Okay, so on to long division. So I took this problem, x squared plus 15x plus 50 divided by x plus 5, and I wrote it out as a long division problem. So this divided by this means we're going this denominator into the numerator. And then I set up a long division over here just to remind you of the steps of doing this with numbers, because it's not like anyone does this anymore with a phone in their pocket. So let me kind of remind you with an easy problem what that algorithm looks like. So when we're doing numbers, we go 5 goes into 13 twice, right? And then the 2 goes over the 3 because we're saying it's going into the 13, not the 1. So we're putting it over the place that it's going into. And then 2 times 5 makes 10. And then we come down and we subtract. And then we bring down our 9 and we go again. So I'm going to do that exact same thing over here, except here it's easy to go 5 goes into 13 twice. Here x plus 5 goes into this is not a very comfortable way of thinking of it. So what you want to do is we're going to try to go this minus something below it, and we want those to cancel. We want it to be 0. So what we're thinking is, what do we have to do to this x to make it look exactly like whatever's here? So what do I multiply x by to make it x squared? And the answer would be x. So I'm putting the x over the x column the same way that I put the 2. 2 times 5 made 10, so the way that this is lining up the same way. And then 2 times 5 is 10, so here we go, x times x plus 5. So the math I'm doing is x times x plus 5. But it's written in this way that really screws people up, because I'm going to x times x, x squared, x times 5 plus 5x. But same here, x squared plus 5x. So I'm just doing that, but kind of written in this funky way. Here we subtract, here we also subtract. Here, 13 minus 10 is easy, it's 3. Here, this is a slightly trickier because people forget that we're subtracting this sign. And so a lot of times they would get a 20 here. It gets worse when this is a minus, you'll see those coming up. But this is going x squared minus x squared, that cancels. 15 minus 5, that would be 10x. And then what did we do? We brought down our 9, so here we bring down our 50. So for this example, the next thing we do is go again. And we go 5 goes into 39 7 times. 7 times 5 is 35. Subtract, and 4. So this 4, sometimes we write it R4, or sometimes we write 27 and 4/5. So 4 out of 5 parts. 27 wholes and then 4 out of 5 parts. We can use that same notation over here. So here, what do I multiply x by to make it look exactly like 10x would be a 10. And then 10 times x is 10x. 10 times 5 is 50. And remember on the last page, this went in, it factored and canceled. So I should get remainder 0 here because this is like, 3 into 24, where it goes evenly. And that is exactly what's happening. So 10x minus 10x would be gone, 50 minus 50. So there's a remainder 0. So there's the exact same x plus 10 that I got on the last page by going x plus 5, x plus 10, x plus 5, and canceling. So if you're comfortable with factoring, that's a lot easier than going through all this mess. But again, this only works if it factors. If I change that 50 to a 49, all of a sudden this no longer factors, and now we have to do long division. So that's one of the reasons for having this other method. I'm going to do the same problem a third time, and this time I'm going to use synthetic division. And so I'm just showing you the same example 3 times in a row. Once by factoring, which again doesn't always work. Once by long division, which always works. And then now I'll do synthetic division, which works. If this is a 1x, it definitely works. And then there are other circumstances where it can be handy, but is in a little bit different application. So for synthetic division, what we do is we set up this kind of weird division bar. And then inside, I'm going to go, so this is 1x squared plus 15x plus 50. So I'm taking the 1, the 15, and the 50. And right here's where people are like, oh, I don't like this. I don't want to do this. Trust me, this it turns out really good. So x plus 5. So the sneaky little bit to synthetic division is whatever is right here. So our x plus b, whatever's that factor, we're doing the opposite of it. We're taking the 0. And so in this case, the factor would be x plus 5. So we're going to use its 0, which would be negative 5. So if this had been x minus 4, I would use positive 4 in this spot. So we're using the 0, the sign of the 0, rather than the sign of the factor. And then it's kind of, this is a little witchcrafty, but it turns out really good. And I'll show you what, I can compare this to that and show kind of what the methods do once I do it. So for now, just bring down the 1, trust me on that. And then we're going to go negative 5 times 1. And that will be negative 5. And that goes in this next slot. And then we just do whatever math comes up there. So this says 15 minus 5. Cool, that's 10. And then we go again. So now we go negative 5 times 10. And that makes negative 50. And then we just do whatever math that says. So 50 minus 50 is 0. Before I explain this, let me say everything I just said one more time. It's a little, like I said, it's a little hard to follow at first, but once you get the pattern, super easy. So we're going to bring down the 1, first move, and then we went negative 5 times 1 is negative 5, and that went there. So then we went 15 plus negative 5, or 15 minus 5, however you want to think about it, but that makes 10. So now I'm saying negative 5 times 10, negative 50, 50 minus 50, that's 0. So what did we do? Well, we went x into x squared, so that means this is always going to be 1 degree less. So 1 degree less of x squared would be x. And then counting down, that makes this one plus 10 remainder 0. So it's the exact same answer that I got, x plus 10, x plus 10, x plus 10. It's just 3 ways of getting there. So I meant to come back to this one and then kind of compare these two methods, and I think I forgot at the end. So what we're not showing here is these things that are canceling and just coming out to 0 every time. So that math isn't being shown. The one that we brought down was because this was x into x squared, which is going to be a 1. Here's the 15 minus a positive 5 is the same thing as 15 minus 5, and that made that 10. There we brought down our 50, and then 50 minus 50 is 50 minus 50, and there's our 0. So the only math that's keeping track of is these two pieces that mattered, not the pieces that just cancel. So that's why this is so much shorter than this over here. So both methods have their place, and I will do some more examples here of each version. Okay, find the quotient and remainder when the first polynomial is divided by the second. So this one has a 2x in there, so that means we are not going to use synthetic division because of the 2. So synthetic division is only good when we have a plain x term. So here we're going to set up 2x minus 4 into this thing. Okay, so what do I multiply 2x by to make exactly 2x cubed? I got the 2 and the x, so what I need is another pair of x's, right? So that'd be x squared. So that's going right there. And then I go x squared times 2x, 2x cubed, x squared times negative 4, negative 4x squared. Okay, so 2x cubed minus 2x cubed, those cancel. This is so tempting to get wrong because you see a plus 4 and a minus 4 and you're like, yes, those are gone. No, they're not, because it's plus 4 minus negative 4. So that's really plus 4 plus 4. So this should be 8x squareds. And remember, we're just collecting like terms, so this is not changing these x squareds. We're just saying 4 minus negative 4 of those. And then bring down our negative 14x. So now what do I multiply 2x by to make it look exactly like 8x squared? I would need a plus 4 to make the 8, and I need one more x to get to x squared. So 4x times 2x would be 8x squared, and then 4x times that negative 4 makes negative 16x. So 8 minus that kind of mangled 8 would be 0. Negative 14 minus negative 16, so that's negative 14 plus 16. So that's 2x, and that's the spot where long division is really hard. And then we bring down the 15. So now what do I multiply 2x by to make it 2x? Well, 1, because it is already 2x. So that would just be a plus 1 there. So 1 times 2x for 2x, and 1 times negative 4 for negative 4. And those are gone. 15, or minus 15 minus negative is minus 15 plus 4, so that is negative 11. So then this one, it would be, oops, you know what, I just realized that 15, I miscopied that. That's a minus 4. I was just checking my notes going, why did I not get this right? So that should be a minus 5, and then minus negative 4 would make that minus 1. There we go. Okay, so then our answer is x squared plus 4x plus 1, and then this minus 1 over 2x minus 4. Okay, so same directions. This time this is an x squared minus 2. We're dividing that into 3x cubed minus x squared plus 3. So this one is a little bit different in that we have all kinds of missing terms going on. And when that happens, we need to have what's going to be placeholders so that we keep organized. And let me set that up. And it really doesn't make sense until you see it kind of done out. So bear with me for a second. So I'm gonna, yeah, I should keep you here while I write this because I need to tell you what I'm doing. So I'm gonna go x squared plus, this is jumping the 0 term. So I'm going to go 0x minus 2. And that 0x, what that's going to do is keep things spaced out right. Because even if I don't have a linear term in this, I'm going to have linear terms over here. And even if you don't see them right now, I will pick them up as I go. And so I need to have that there to keep everything basically in alignment. And then this is going to be 3x cubed minus x squared. No linear term again, so I'm going to call it plus 0x. Sometimes in class people will say it should be plus rather than minus. It doesn't matter, it's 0, so either one's fine. You usually just put plus, and then plus 3. So here we're going to go, what do I multiply x squared by to make it 3x cubed? So I need the 3 and I need one more x. So I'm not over my x squared terms, right? I'm multiplying it by 3x. So right there, that's where I need that linear term, because that's actually where my answer's lining up. So I need a place to put it. So that's what this was all about. So here we go, 3x times x squared is going to be 3x cubed. 3x times 0, that's nothing. So I'm gonna call that nothing, plus 0x squared. You could also leave it blank, but I'm just going to kind of emphasize where the x squared term is landing. And then 3x times that negative 2 for negative 6x. And then we're subtracting. So 3x cubed minus 3x cubed, gone. Minus x squared minus nothing, so that just is minus x squared coming down. And then 0, because we didn't have anything there, so we need the placeholder, minus negative 6 is really 0 plus 6, so that would be 6x. So you see how even though we didn't have x terms in our original polynomials, they're showing up all over the place as soon as I start doing the work. So that's the point of the placeholders. And then we'll bring down that 3. And then we just ask ourselves, so what do we multiply x squared by to make it look just like this, or negative x squared? And that would be a negative 1. So negative 1 times x squared is negative x squared. Negative 1 times 0, nothing. And this time I'll denote it with a nothing there just to show that version. And negative 1 times 2 would make a plus 2. So here it's a mess, but it's correct. Minus x squared minus negative would be plus, so minus x squared plus x squared cancels. 6 minus nothing would be 6x. 3 minus 2 would be plus 1. And then notice I'm having to get into fractional things. I have x squared, I only have x here. So that means I'm done dividing. So my solution would be this, the 3x minus 1, and then plus the remainder, 6x plus 1 over the divisor, which was x squared minus 2. Okay, so for this one, what do we multiply 3x squared by to make it look like negative 15x cubed? So we need a negative 5 and then an x. So we're in our linear terms, so I'll come over here and go negative 5x. And then that gets me the negative 15x cubed we're aiming for. Negative 5x times negative 4x would make 20x squared. And negative 5x times negative 2 would be positive 10x. But then all of that is being subtracted. So then we just have to be careful with signs. So minus minus is plus, and that cancels. 14 minus 20, negative 6. 14 minus 10, 4x, and then bring down the 7. So now we have to go, what do we multiply 3x squared by to make it look like negative 6x squared? So that'll be negative 2 times 3 would be negative 6x squared. Negative 2 times negative 4 would be plus 8x. Negative 2 times 2 is plus 4, parentheses, and that drops out. 4 minus 8 is negative 4x, 7 minus 4 is plus 3. And so then our answer will be negative 5x minus 2, And then this, I'm gonna guess, I think they have an answer box, and you're typing that into the box, and then this is already typed out for you, and then you're typing that into the other box to try to save a bit of typing on it. Okay, so then for this one, use synthetic division to find the quotient, and this time we can because this is a 1x squared. Let me write this a little bit bigger. So here's what I'm given, and we're dividing that by x minus 2. So for x minus 2, the 0 of that would be 2. So we see a minus 2, we use a plus 2 because we want what makes it 0. And over here, we have 3 and then negative 5. We're skipping that linear term, so I'm going to put a 0 there as a placeholder, and then 2. So this would be like the 0x that we saw in those earlier problems. So here I'm going to bring down the 3. 2 times 3 makes 6. And then you just do whatever math this says. So negative 5 plus 6, you're adding, but it's just you're combining the signs and however they look. So negative 5 and 6 would make 1. 2 times 1 makes 2. 0 and 2 makes 2. 2 times 2 makes 4. And 2 plus 4 makes 6. So we're dividing x into x cubed, so that means this would have to be x squared. So it's always going to come out 1 less than what you started with. So this is 3x squared, and then plus 1x plus 2 plus 6 over x minus 2. So synthetic is really, really easy when you get to use it. And this last one, I did x minus 2 again. I don't know why I picked the same thing. That was kind of silly, but I did. This is x to the 4th minus 29. So x to the 4th has a coefficient of 1, and then I have no x cubed terms. I have no x squared terms, right, because that was x to the 4th. So no x cubed, no x squared. I have no x term. And then for my constant term, I have negative 29. And the zeros are fine, they're just going to combine like they would. So here we bring down our 1, and I go 2 times 1 is 2, 0 and 2 makes 2, 2 times 2 makes 4, 0 plus 4 makes 4, 2 times 4 makes 8, 0 and 8 makes 8, and 2 times 8 makes 16. Negative 29 and 16 leaves negative 13. It started off x to the 4th, we're dividing by x, so that means this will be x cubed. So x cubed plus 2x squared plus 4x plus 8 minus 13. And again, depending on how they have it set up, they might have a box with a plus there, so you'd say plus minus 13, or you could just say minus 13 if there's no box over x plus 2.